Jump in, ready to go?
Okay, hey, good afternoon, everybody. Welcome. Happy Thursday afternoon, April 18th. This is session number 9. We have 3 more to go in the series, so thank you first and foremost for showing up. We'll have a fantastic hour today, or whatever, 58 minutes. And hopefully the quiz is going to be who can actually create a run chart. So Roberto is going to take us through, and then we'll have some fun. Okay, Roberto, turn it over to you and Nisha.
Great, thank you. And slight correction there, 7. Session number 7.
Devin, oh, bummer.
I know, time's going, right? Well, we'll get there. So, hey, hello everyone. Thanks for returning, and excited to have you all here. Today will be a fun one. This will be run and control charts. I will do try and do as best I can on a nice balancing act between an introduction, a little bit of into the weeds. There are plenty of opportunities to go even deeper for those who are interested. Please reach out. Happy to chat even further, or maybe even give us some feedback on maybe you want some more. So thank you. All right. First slide. There we go. All right, so session outline. Be kind, please rewind. This is where we'll review a little glimpse of what happened during our last session. We will have a little reminder on measurements, as we spoke about, I think, in session 2, session 3 a little bit. We will talk about understanding the purpose and use of run charts and control charts. Then certainly develop skills in creating those run charts and interpretation, a very important piece. And interpretation goes along with the actual analysis of what your data is saying to you to drive further improvement. All right. Great. So last time, these are some quick images just to kind of remind yourself of what was going on here. Last session was all about mapping, and specifically we dove deeper into value stream mapping. You learned a little bit about enough about process mapping to understand the step-by-step process that showcases a visual of a workflow. And then we learned about value stream mapping and how it differs. It's a more, I would say, robust version of a process map. And you can see that on the top left image. That is a very outline structure of a value stream map. That middle component, if there's 3 layers, the middle layer right there is essentially a process map. The top layer is all talking about the various communication that happens in a value stream mapping workflow. And then the bottom section is identifying the various time sequences. So we're talking about cycle times and wait times. And that leads me actually to the next bottom section there, which highlights some key terms to just again remind you all what we spoke about. Cycle time, the time it takes for a certain process to occur, to happen. Lead time, think about that as stacking up all of the cycle times and wait times all together. And then maybe a little bit of cart before the horse there, but wait time, what's happening between each step in a certain process. Tact time, this is all about opportunities for doing a certain thing, so demand. How much time do you have to get something done? And if you do the math there, you're able to identify, okay, I need to do a certain sequence of events. I have X amount of enough time. If I divide up that time by equally, and I know things aren't all things equal, but if you were to divide up that time equally, then you're going to say, well, each step takes another this much time, and that helps you to kind of reframe kind of tact time. What does that look like for you? And then we talked about value added, non-value added, and necessary, but non-value added. And those are judgment calls in which you'll identify, okay, well, it took 1 hour, 2 hours, 3 hours, days, weeks to do a certain process or a step in that process. And you have to evaluate, well, how much from the customer's perspective is value added to them, non-value added or necessary, but non-value added. And we talked about, before you get into actually mapping the value stream map, you need to do some background research. And one of those really great I guess I don't know if you would say tools, but methods that we know from Tai Chi Ono is going to the Gemba, and if you stand in place and watch the work happens where it's happening, you'll learn a whole lot. And this is where you take the opportunity to maybe not speak to anyone, just kind of at first stand, watch, and just see what's happening here. Watch people moving around, watching materials moving around, just seeing the environment do its thing, live. And then certainly there's opportunities for you to ask more questions as you need it. But from that, you're instead of, let's say, sitting at your desk looking at some data, looking at an email on someone describing a process, you seeing it yourself is very, very valuable as you continue to understand the process. And the far right side are a number of icons that we utilize in the value stream map. And they're helping to identify for that reader what's happening. Was there phone communication, email communication? Was there any shipping that happened? Was there any, what was the actual step? Can you showcase the decisions on what's, or the time captured, the cycle times, or decisions like I was mentioning, value added versus non-value added, and so on and so forth. So hope you all learned a lot. And there's our little rewind. All right. Now moving forward into what we're talking about this week. And we're going to be talking about data. And of course, data is associated with various measures that we decide on the front end of our project. And we talked about this early on in our seminar here, or series. And we had talked about 3 different kinds of measures. There was the outcome measure, process measure, and balancing measure. Okay. And just again, refresher. So the outcome is like your endpoint, your overall goal of your project. There's some verbiage there that might get a little detailed, but it's a dependent variable. And I'll get to that soon, a little bit more about it. But the next measure is a process measure. These are the focus on the steps in a process towards an outcome. I'll speak to those 2 really quickly. So remember we talked about process map. There's various steps that happen and that need to occur. So if you want to measure one step in the process, great. Or maybe you're going to measure all the steps in the process, whether it's cycle times, whether it's efficiency and performance or volume, whatever it may be. Know that ultimately those processes lead towards a final end. And that final end could also be measured, and that would be your outcome measure. And so that's where the dependent versus independent comes in. The process measures are potentially independent from anything else. So those are your starting blocks. Those are isolated. Those are, I can make a change to that. And there's no other confounding other things that are contributing towards making that measurement tricky. However, many process measures potentially influence your outcome measure. And that's why your outcome measure is dependent on your process measures, right? Because your process measures change around, you can do some variables. Your outcome measure will change as a result of your process measures. Okay. And then there's the last thing was balancing measure. And that has to do with you making sure what you're working on doesn't negatively impact another area. So you're being a little bit forward thinking, you're thinking about the entire system that you're working on, and okay, you have scoped out and isolated what you're improving, and you don't want to accidentally go outside of that scope, outside of that box, and influence something else. So whatever that something else is that you identify would be one of your balancing measures. It's something you're watching and keeping track of to ensure, okay, if that doesn't change, that's an important thing because I don't want to negatively impact that one thing. Okay. All right, so bear with me here. I know this is data, stats. We're going into it. And so definitely feel free. Remember, raise your hand, add to the chat, whatever you'd like over during the course of this session to make sure you know and I know where everyone's at and what I could add more to. Okay. Run chart versus control charts. So, all right. So we have our measures. We just talked about measures. We talked about the various measures that we want to identify and select so we know what are we trying to impact in our performance improvement project? Well, once we have data, and I'll call them data points, and I'll get more to why I made data point, but there are two kinds of charts that we can select from to use, and you'll see these visuals very, very soon. The main components that, if I can flip back and forth, but the main pieces are what is the central line that's going through this data. Central lines, think of this as it can be, if I have numbers 1 through 10, you could say, well, what's that middle number? Well, it would be 5.5, right? So it's, wait, no, 5. So it would be what's my average or what's my mean, and then run charts utilize the median. So this gets a little trickier. So some of you I know have had previous instruction in stats, and so I definitely want you to think back and remind yourselves what was that? What was that thing? So know that there's a certain chart called a run chart, and we'll go into what that looks like, and it uses the median versus a control chart utilizes the mean, or otherwise known as the average. So if you remember how to do the math on the average, you take your numbers and divide it by the total amount of numbers, and you get so 10 divided by 2 is 5. Okay, so that's your average versus median. You have your numbers and you're finding the exact point of all of those numbers. So if you have an uneven number of 1 through 11, 1 through 10, and you're trying to find the exact center point. It's not just divided by 2, but it's the exact center point of all of those numbers. Bear with me. Bear with me. All right. And then there's data points. For run charts, you will want to use 11 or less, or you have 11 or less data points or pieces of data. Control charts, it's more, think of it more long term. 12 or more, if you have 12 or more data points, go ahead and utilize a control chart. You're ready to go. And the differences in use, I like to say that a run chart is usually at the very start of a project. Again, you have 11 or less data points. So you are trying to simply track where is this, what's going on with your data at an initial point. And the control charts, you'll learn that it's more robust, and I'll share more about what that means. And so you have 12 or more data points, use a control chart. And the special features that you'll see is run charts are data over time, and control chart being more robust is data over time, plus it has these things called control limits. All right, so what is a run chart? Here's a little visual here. So main thing is I'll jump into, it's a basic graphical representation of data points over time. And if you remember graphing and you remember your school is on this, you have this vertical axis, and that vertical axis is your y-axis. And then you have a horizontal axis, and that is your x-axis. Okay. And so your x-axis is typically your time sequence, and then your y-axis is typically whatever it is that you're measuring. Right. And then, as I mentioned, data points. You can see on this image here, those are represented, and you see these little red boxes. So data point, it's a point on your graph. And you connect these points in a chronological fashion, and those lines help you to more easily see certain things that are happening with your data. Now, this is a little initial shot of a run chart with certain rules for interpreting what is happening to that data. And we'll go more in this very, very soon. But just kind of give you a heads up there. We're going to learn soon about things called a shift, not optical data point, or trends. Okay, so going into these rules. So you have your data, and you have now put it onto a run chart. So you have what's happening to your data over time. So you have, I think I had utilized in the past, patient falls, or we can go with that. There are, we don't want patient falls happen in our facility. And so maybe we'll identify if we have a count from 0 to 30 or whatever it may be, we may signal for the reader actually on a chart, and you'll see this later on, a down arrow. So down is good. So less falls is good. And so if you have, well, this isn't necessarily speaking to a fall, but just say there's whatever it is that we are measuring has 27. And that happened in January. That is obviously an old chart here, but 97. So one of your data points will say, whatever it is that you're measuring, there's 27, 28 of something that happened in January of 1997, and so on and so forth. You can see that now the next whatever it is that you're measuring, there was 20 of something that happened in March, let's say. So that's your data over time. And now that it's plotted, you can start identifying certain themes that are happening. And that first thing is a shift. And so a shift, as you can see here, is 6 or more consecutive points, either above or below the median. If you remember, I said that this is a run chart, and a run chart utilizes a median as a line through the middle of all of its data. So that's what you see there represented in the dotted line going through your data. So if you start seeing a pattern there, and you can see in that first segment there, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points before it crosses the median line. That first bundle would be identified as a shift. Okay. And then you can see that there's additional little packets there until it crosses the median line again. So these are signals in your data that something special is happening. And I think I have a slide later on that actually talks about the differences, and I probably should have put it earlier. You know what? Let me go forward real quick and get to that one slide I'm talking about right here. I should have had this one earlier. So this is important because we're talking about signals, right? We're talking about something as special is happening with your data. So I first really need to introduce to variation within data. Know that there is two kinds of variation within data. There's a thing called special cause variation, and there's another item called common cause variation. I put this image down below of a boat on water to help describe what I'm talking about. And if you were to kind of put yourself in that imaginary scenario, you're on a boat. Okay, it's spring, almost summertime. We all want to maybe be on a boat, hang out. Hopefully, you don't get seasick. And if you've been on a boat, you know that there's waves that are going to be touching the boat, and the boat, if there is a little bit of windy day, you'll have a regular up and down motion while you're on the boat, kind of going up and down. Hopefully not too much, right? Avoiding that seasickness, and hopefully you went on a good day. But you can expect a regular rhythm going up and down on the boat. That is associated with there's a common waves, right? There's a common pattern happening. That is similar to what we're talking about here about common cause variation. I'm regularly expecting to go like this on my boat, and so on and so forth. Now, there's some scenarios here that you would say something special happened that happens to the waves, to the water, that causes this interrupted pattern. And you might say, well, there's a huge whale breach. Let's say I'm whale watching. And there's a whale that comes out of the water, breaches, and slams next to the boat. What would we expect there? We would expect certainly us to be excited, surprised, but also a little bit of a difference, maybe a different sway, maybe a higher up and down, something like that. Or a speedboat comes past us, maybe a jet ski, whatever it may be. There's something different that has occurred outside of me just kind of hanging out and just enjoying the up and down motions of the waves. So that thing that's special, that changes the regular experience that we were having would be something special. That's what happens with here in our data. And you can say, well, with our data, apply that to now thinking about, okay, so if data is supposed to be, now you can see there on the top part, that top image there, data is going up and down, up and down. Okay. And data does that, just like waves do that, up and down, up and down. And there's some sort of expectation of, well, a wave going this high versus this low, this high, within certain reason is what we would expect. But only when that wave, that whale breaches and slams next to us, does something special happen, and it causes a difference in our wave length. So just like with your own data, when you're thinking through, okay, I am, let's see, who was doing, was there any projects that we can provide as an example that I was speaking about? Happy to bring someone's kind of project into this. Letty or
Hi,
Janet.
Roberto.
Hey,
Maybe when we were doing the CG caps for patients, when we were tracking their breast cancer, oh gosh, I'm so sorry, I'm drawing a blank. Like colon cancer screening, breast cancer screenings, where we were doing fit tests, making
Yeah.
sure calling patients to do their mammograms.
sure.
So we did have these reports that we would run.
Mhm.
So nursing staff would be assigned to their dyad, and they would run a report that shows them patients that are due for mammograms, pap smears, colon cancer, fit tests, and we would go over these reports monthly. But I believe there was like a grant tied to it. This was a few years ago.
Perfect. Thank you, Letty, for that example. So let's just use that, just a little grab of that, just to, again, application. So if we're talking about screening, we say mammograms, but for cancer screenings, preventative cancer screenings. So if we have one of your projects was associated with patient outreach, right? So we do a special effort to engage the patients, and whatever intervention we're doing, we are trying to encourage greater participation in these preventative screenings. So if we do nothing at all and let just time run, and we the only intervention that we're doing was, let's say, an email blast out to those individuals, maybe on their birthdays, whatever it may be, and we make no other changes, we should see common cause variation in our graphs, ups and downs within a certain limit of what we would expect. Now, certainly if we apply a new intervention, such as now we're going to do a little bit more aggressive and we're going to start calling folks, we would hope that our intervention, fingers crossed, it will spark interest and we will have more people coming in to do those preventative screenings. So in our data, we will have, if we're talking about volume of patients coming through, we'll have more patients coming through. In our data, we should see, if up is good, because up is maybe associated with volume increase, we will see our data increase. That, if we apply certain rules that we're going to learn more about here, we're going to be able to say, oh, gotcha, my intervention did something, and it impacted my data in this way. So something special happened. All right, I'm going to get back to this. So with variation, again, common cause versus special cause, and overall, our goal in total is to reduce variation, whether it's in patient harm or any outcomes that we're trying to achieve, right? We really want to have more, I guess, expectations, or built-in expectations of what we should see over time. Okay, so I'm going to go back real quick again. So now that we know about variation, I can now speak to these different rules. So there are certain sequences of data points on your graph that signal a certain something. So this one, 6 or more consecutive points above or below the median line, would represent a shift. Now, a shift versus a trend, and a trend would be 5 or more consecutive points, all going one way or another, up or down, and regardless of whether it goes through the median or not. The main point I want you to take away here is not that a shift or trend is signifying that it's a whale breach versus a jet ski flying past your boat. Not that this data is going to necessarily tell you which one actually happened, but that something happened, and that it deviated from the expectation of that normal up and down on your boat. So again, you're identifying that there was something special happened as applying these rules. And if something special happened, then we can start asking more questions around, do we know why it happened? Okay. There's another rule for run charts. It's associated with runs. This one's a little bit more technical, or it's a little bit more work to identify this rule when it happens, and it actually requires this little run table chart here. And the main takeaway is that, as I mentioned, up and down is the normal expectation for being on that boat. Well, what if at some point in time, sure, I'm still going up and down, but what if it's taking me longer? I go up, I wait, and then I go down. And then wait. I'm still going up and down within the expected how high, how low type of thing, but it's not happening as usual or frequency as I would expect. That in itself is a special cause. Or maybe I could say conversely, I go the same amount of up and down, but it's like this. So again, something special is happening that I need to pay attention to. And last rule here is what's called an astronomical point. And this is something where you eyeball your data and you say, well, you're looking at this graph right here. There's something that sticks out like a sore thumb. That sore thumb right there is what's known as an astronomical point. It's completely different from all other data points. It's either higher, it's lower. It's something that you're saying that one of these things is not like the other, and that might be my my whale breach right there. I was going up and down, just fine on my little boat there, and all of a sudden, whale breach, boom, wave went up sky high and then back down. Okay, so again, a trend, a shift, a run, an astronomical point, it's not necessarily telling you exactly what happened there, but it's telling you that something special happened. All right, now we're going to switch over to control charts. I gave a little intro to this. Control charts, very similar to a run chart. However, more robust, more sophisticated, and this is what type of graph I suggest you use as you progress through your improvement project and you have 12 or more data points. Now, you can see here what's the anatomy of a control chart. You'll see, okay, I have a blue center line that's going through my data. Now, the difference between that is this one is going to be a mean, or otherwise known as the average of the data, okay? And then you'll see some dotted lines going above and below your data. These are called upper control limits and lower control limits. Taking a step back, not to get too technical to this, which I might get into my next slide here, but think of that about expectations. This is where some of the language around Six Sigma comes around. If you've heard about Six Sigma, and again, I'll go more into this next slide. But just simply stating, think of this as these are parameters in which I expect my data to be within, like boundaries. And so if it ever goes beyond this boundary, then it's an easy way to quickly identify that something special has occurred because I set boundaries. And then and as we'll learn about, when it goes out of those boundaries, if you remember the last I think it was last or second to last chart I showed, which was an astronomical point. So we'll get there. But you'll see again, here's my data. Here's my data over time, right? Y, x-axis, mean line, and then I have control limits that help to identify what should I expect my data to be within. And I'll go later into recalculating control limits. Again, this is meant to be a general kind of breadth for you to understand what's going on here. Okay, so I won't spend too much time in this. This is more detail than what you need, but understand that if you've heard about, we talked about lean, we talked about Six Sigma, and we talked about it's sigmas are different from standard deviations, but for sakes of simplicity, very close to. If anyone's taken calculus here and learned about standard deviations, or even if you've been certainly in a course in which you've your teacher, your professor who has graded on a bell-shaped curve, if you remember that phrasing, you'll know that the bell-shaped curve is that image to the left. Now it's tilted on its side there for a reason, but you might remember from your school days that bell-shaped curve, there's a certain, the bulk of the class will be receiving this grade on a given test or a grade at the end of the semester. And then there'll be a select few who will not be the average of the class and maybe on the tail end and didn't do too hot, maybe didn't study so hard. And so hopefully that's just a small handful of people. And then there'll be those other small handful of people who are spectacular ace students, and they get 100% across the board. And if a whole class does that, fantastic. But most likely we see on average that that's not the case. You'll have some people who didn't study too hot, some people who gave A efforts, and then the bulk of the folks in the class right there somewhere in the middle. Okay. And while standard deviation and sigma are different, I'm just for sakes of this conversation, I'm not going to go into details here. Pretty close. And so if you were to put your bell-shaped curve on its side, you can see what I'm talking about with a control chart. And you'll see the control chart, you have a middle line, which is your central point, and that would be the bulk of what we would expect our data to be. And then you have the upper and lower control limits, and those are the edges of that bell-shaped curve. And so the closer you get to that edge of the bell-shaped curve, think of those as those very, very little data should be getting closer to those edges of those upper and lower control limits. So the bulk of it should be closer and closer to that central line. Okay, an important point there is when you do Six Sigma, 99.7% of all of your data points should be confined within those upper and control limits. So I can say 0.3% of your data points may fall outside of that. And those, you'll see soon, would be considered astronomical points. Okay, here's that slide on variation. And I'm going to do a little mentioning of the color coding here. So there is, the program I'm using here is QI Macros. It's a add-on of Excel, and I'll talk more about this at actually another session. But just for sakes of you're seeing blue and then you see red and you're like, well, what's going on there? The blue represents common cause variation, that that program itself is saying, oh yeah, no problem. It's within expectation. And then the red areas are the system identifying that something special had occurred, a special cause variation, meaning that data section had resembles one of or meets the criteria of the various rules that we had talked about before, a trend, a run, a shift, all of that. Okay, so red, special cause, blue, normal cause variation. Think about it as regular noise or me on that boat, just regularly going up and down, and we're fine. So I think we're going to be able to fly through these next maybe 3 or 4 slides here because you're going to see some consistency with what we just learned about with run chart rules. There's a little differences in the count, but you'll see a shift. In a control chart, you can also identify a shift. However, in this phase, you need 8 points above or below the center line, which is your average. And as I mentioned, should only happen 0.3% of the time. It's something special happening. Okay, so you can see blue, blue, blue. You can see red. You can see blue. You may say, I'm sure I use the P chart on this one, and you may say, "Whoa, what's going on with the upper control limit?" It's not a flat line. It's doing the zigzag stuff. Again, probably more than you need, but a little primer. P charts is talking about percentages, and it's really speaking to volume. So what this chart is doing is it's understanding the differences in volume over time. And so because it's calculating in volume, it's adjusting the expected upper and lower control limits over time. I know, not so fun. Hopefully you're kind of floating along with me here. So that's a shift, and so that's represented in the red, and so that would be a special cause. Oops. There. Okay. Then you have okay, I skipped past trend. Then you have trend, 6 points increasing or decreasing. Again, we saw this in the run chart, just a little difference in the count. So this is 6 points increasing or decreasing. Again, it's identifying something has changed in your data, and it's all flowing one way, even though it crosses the mean line. There's another rule called with hugging. Very similar to, I mean, not very similar, but it's kind of that thought process of the frequency of data crossing the median line. And so in this case, it's really talking about not frequency, but the amplitude. So are they within a certain sigma within your central line? And if you remember that graph over here, here's your central line, 1 sigma, 2 sigma, 3 sigma, and then a total 6 sigma. And so what they're saying in this graph here is there are 15 points inside 1 sigma above or below the mean line. So it's something special happened, right? Remember, it was that me on the boat, and I was just going up, I was going down, but not as high or not as low as I thought I would. So something special is going on. And then you have your 1 point above the upper control or lower one, and that would be your astronomical point, otherwise known as. And so you can see you have that 1 point right, if you can see my cursor right here, and that is above your upper control limit. And so that would be outside of the expectations of what you were expecting to see, and so that would be an astronomical point. So again, something special happened. All right. So I had another slide talking about goals. What are you trying to achieve? So overall, we're trying to reduce variation. Again, here's a control chart. You got your Y, you got your X, you have your data over time, and you're seeing that, okay, your data is all in blue, so the system isn't picking up any signals. You can see that it's between the upper control limit. Gotcha. Okay. All within expectations. Let's say we put a little icon on our graph that says down is good. Okay. It's going up, and that's not necessarily a bad thing when it's going up. It's just because there's no signals being called out. None of this data is meeting any of the rules that we identified. So this, even though it's going up during the point where it's saying good, it's within reason. It's just fine. It's data that's just going on and on. So what we could do, if we want to, let's say, add a little additional critique to our data, let's say, okay, my data is going up and down. I'm on that boat. I'm going up and down as I would expect. But you know what? It's within expectations, and I'm measuring how the waves are going on this hitting the boat, and there's nothing really fun happening here. I'm trying to maybe do some type of experiment. I'm trying to measure me maybe throwing a little pebble or a little larger rock and seeing if it does anything to the boat. And because I throw a rock versus a breached whale, right, it makes a huge change. A rock really isn't going to, yay size rock, whatever it may be, isn't really going to make that big of a difference in a wave that touches the boat. And so I now need to be more specific. I need to actually, let's pretend I need to look closer at the waves to see, or the boat to see, how much is this really, this me throwing this rock next to the boat impacting it versus a huge whale. Well, that means I need to, it's almost like I need to get a magnifying glass and I need to look closer to how the boat adjusts. And that's the same kind of concept of what we're doing here with changing the upper and control limits. We're stressing the system. We're saying, you know what? I don't want my parameters to be only 0.3% outside of only 0.3% of outlier data are astronomical points. So maybe I want to look closer to see, are there any other data points that are outliers? And so I'm going to put a magnifying glass and slim down my upper and control limit. Thus, more data will flow outside of those expectations as I see my data. So I might say, instead of 6 sigma, I want 4 sigma. So I'm going to cut out 1 sigma from the top and bottom, and thus I'm looking closer and critiquing my data further. Again, this is a strategy of how to fine-tune your measurement strategy to be more critical, to see if you can potentially improve further. So now another opportunity is to even adjust your mean line. You can decide, I think there's an image here, you can move it down, you can move it up, and this would say, I'm going to, let's say I did an improvement, and Letty, you had mentioned your, let's say, interacting with the patients and influencing with their participation on these screenings. Gotcha. So let's say I did make a change, and I'm now seeing, remember, up is good because I have more people coming in, and I'm going to say, you know what? I made a change, and I'm going to go ahead and say, at this point in time, I'm gonna measure if my change made an influence, and I'm going to track that over time. So I have data. I'm going to adjust my mean line to that new possible norm. And I know I'm going to start maybe losing some people here, but think of it as I had. Remember, I had my set expectations with my upper and lower control limit. I have a mean line, which is right between the data, right? But let's say I do something and I get more data, I get that up, right? More volume of people participating. So I will then say, great, I'm expecting more. I have a new data point that brings me up 10, 15, 20 people per month that are coming in to do this screening. And I want to measure that as my new norm. And so while the data itself may not be there as the mean line, you're forcing it to say, what is it going to look like if I have my data, the new norm to be this as the middle line? That's my goal line now. So instead of having, I'm just again making it numbers, 50 people per month doing this screening, now I want it to hit 70 people a month doing this screening. So that will be my new goal, and I'm going to see if my data follows with that. Okay. So actually, I think I spoke too soon. So this one talks about that adjustment. So once the special causes have been eliminated, then and only then is it possible to focus on reducing common cause variation. All right. Another important point here. So I think if you all can think about the various interventions that you're doing as various variables that are impacting your data. If you've done science classes and been in chemistry, whatever it may be, you know that you want to be able to study as little variables as possible to see that variable's impact on your experiment, on your data. So if you have many variables, it's hard to really understand what is the contributing factor towards your data going up, going down, wherever it may be. So again, example with me on a boat here. If I have that scenario, I've got a whale breach happening on my right side. I've got a huge jet ski boat zoomed through my left side, and all of a sudden my waves are going like this. Do I know if it was the whale that did it, or do I know if it was the huge jet ski boat just flying past me, you know, like doing 60 or something like that? I don't know, right? It'd be hard to say what caused that difference in my little enjoy ride there. So if I were to somehow be able to remove one of those variables, and let's say my main focus is I just want to focus on that whale breach. I'm whale watching, I'm enjoying the scene, and what I'm going to do as a preventative intervention is I'm gonna call the Coast Guard. I'm gonna put up some buoys around me, whatever it may be, that's gonna help to stop any of these boats, jet ski boats, kind of coming through into my area where I'm watching whales. So I just removed a variable, right? If I remove that variable so I only have that one whale breach, I know exactly what's happening versus both of them happening at the same exact time. So we want to, before we really start improving things, we want to reduce the variables. Thus, we're reducing variation. And so when I do improvement, I can now focus in and saying, got it. What did my one intervention do? Okay. Great. So as I mentioned in the last slide, you can see here the blue and then red, and you can see a little bit of a shift in that, or an adjustment in that mean line. So you can do a retrospective or a prospective shift. I could say, this is my new goal, and I'm going to watch the data as it related towards my new goal, my new mean line. Or, hey, maybe you totally understand you wanted to run data and you wanted to do a little retro review, and you might find, oh, there's a special cause variation. I see that it's in red, and I can manually say, let me see what the mean line of that new data looks like as related towards that special cause, starting at this point. And you typically do it at the very first point of a shift or a trend, okay? And then you flow it through. Okay. All right, definitely more detail, but now we're getting into rare occurrences. And this is actually kind of a newer thing to me as I learn more about the different control charts and what's useful. You may see some data that goes 1 0 1 0 1 0. So in a given month, something happened, and then another month it didn't happen. Heaven forbid there was a code blue. We don't want a whole bunch of code blues in the hospital, but they happen. And there was one this month, there was none the next month. There was one, or false, whatever it may be. And you take a step back and you're like, what is this even telling me? Is this useful? I don't know if it's useful. I mean, it's telling me that stuff happened. And yes, when it's 0, that would be a good thing, because maybe remember falls or code blues instances, we don't want them to happen. So I want it to be a straight 0, but there's no little nuances in there that helps me to showcase what improvement, if there was improvement other than 1 0 1 0. And so there's these other kinds of charts that you can utilize, and I'll go flip into here, and they're called T and G charts. So this is another kind of like step back moment where I just introduced a specific kind of chart, and that you're saying, well, you mean there's multiple kinds of control charts? And yes, there are plenty of different kinds of control charts that you can choose from, and they all have the rhyme and reason of what to use. I'll show another slide that actually has a little bit of a like a decision tree on which chart you should use given the data that you have in front of you. But do know that there are different kinds of charts. I introduced a P chart, which talks about percentages, C chart that I would say is about counts of data. Again, you'll get more. It's not easy. I mean, I'll admit myself, it is not easy to understand at the very start of your learning. You definitely need to use these charts and start applying and thinking about it to really grasp it. But there are a whole variety of charts. And in these kind of quote unquote rare events or ones and zeros type of frequency, you use these charts called T or G charts. And so T is more so associated with time. And so it's time between events. And I like to think about that one as if you've ever seen a skit or something, I feel like that's the way I know it. Where there's a factory floor and someone on the wall has days since last, accident or injury, right? So days since last injury, and then usually in this comedy skit, oh, there was another injury. We're gonna put gotcha 0. There was just an injury. So that's what we're talking about with this type of chart. It takes away it. Hopefully, these injuries on the factory floor are very rare, and so it's hard to say, right? Imagine what that chart looks like. A control chart looks for you. Okay, if hopefully they are rare. Nothing happened. January, February, March. All of a sudden, you have one. April, gotcha, and then nothing again. May, June, July, right? And then you're saying, well, okay, what is that telling me? Well, if I put in a T-chart and I'm saying time between days, I'm able to look at it a little differently, a little different lens and saying, gotcha. So I want my days between injuries to increase. And if I do interventions associated with that, I should see I should see the amplitude increase. If up is good, days between, so I'll see a higher up. And what if I keep seeing up, 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 right? So days between events as time goes continues to increase. If it's going up, 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 that means there was no event. But that in itself can be identified as, if you remember the rules there, a trend. So it's all going up. Fantastic. There's a special cause variation. What did we do during that time period to keep that going? Now all of a sudden you have days between all of a sudden April. Remember, something happened, boom, plummets. Another special cause variation. What happened here? And G is a little different, and this is more so talking about opportunities between events. So number of successful surgeries between surgeries with a retained foreign object. Oh my goodness. So you know what that one is. Something gets left behind in someone when the surgery happened. We don't want that to happen. It should be a rare event. And well, how many surgeries happen between events? And then you're saying, well, okay, so there was a blip, and this is how many successful surgeries happened. And so now we're understanding again special causes. I'm not going to go into this one, but this one talks about, well, how do you actually perform a T and G chart as far as calculating them into a control chart. Okay, so this is my decision tree that I was speaking to. Dennis, I'm sure you're familiar with this image here. This one helps you, again, not going to go into too detail here, very, very nuanced, but it's definitely saying top left is where you start. And you're asking yourself, do you have 12 plus data points? If you don't, no. Guess what? Exactly what we learned about earlier. Utilize run chart. That's most likely going to be the start of your improvement project. That's what you should use. But if you have 12 or more, move forward, go to control charts, and start thinking through these other questions that you have at hand to then identify the right chart for you. G, T, I, X bar, RS. We can go at length about this. This is easily 2 or 3 additional sessions that we can do just on this and walking through everyone's data, and which we're happy to if you reach out. All right, this is actually my last slide here. This is all about, this is just to illustrate a chart that I liked. This comes from a Nationwide Children's. This is around depression screening. This is an example of what I like to see in a chart, control chart that is kind of fully baked out. I see, of course, my upper control limits. I see my data points. I can see that they shifted the data they shifted the mean to demonstrate when certain events had occurred. There's something called annotation, which is telling the reader what actually happened to make you adjust your mean. And you can see that instead of putting all of the information on your control chart, they actually just wrote A, B, and then put to the side, hey, let me give you a little bit more description here, so it's not just all cluttered. So I like that, and I love telling people that's a good way of adding a lot of information on a single slide. You can see the top right, up is good, desired direction. You can see a clear title there, and you can see the X and Y axes are clearly marked, and you have all of your map down below. I forget what that's called, but yeah, your map down below of what you're trying to achieve. And you can see what a control chart they use, P chart. Awesome. Okay. Whew. That was a long one. 12:59. Questions, concerns?
Thank you, Roberto.
Of course.
Yeah,
Of course.
that was great, Roberto. And then maybe next time we can actually go through and actually ask people if they got any questions, if they actually tried to use any of it as a filler. We're doing one chart. We're trying to use a T chart, Roberto, since you mentioned that. Rare events, number of times supplies are not ready when surgeries need to take place. But
Yeah.
one of our change agents, she said her sponsor didn't understand the chart. It was a rare event chart, but it was very hard to explain it. So I'm going to send her back to your slides and actually have her listen to the presentation. I said, rare events, we wanted higher.
Fantastic.
Days in between, we want to go up.
Absolutely. It
Oh,
happens.
no, this was excellent.
Yeah.
And everybody else, please think about it. This is excellent. Please go back and look at the materials again and listen to the presentation. Roberto did a fantastic job. And then come back with your questions. We might actually do our little, follow-up next time and just say, what questions do you have around data? Because it's so important, especially the 8 different type of healthcare control charts. And when do you use which and how do you actually do it? So thank you all. We're a little over time, but we're 1 o'clock exactly.
Look at that.
So Nisha, surveys, if everyone completes their survey so we can give you credit. We got a few more classes to go, and you are the group who's hanging on, so we definitely want to give you credit in your certificate for completing the course. Thank you again, and take care, and everybody have a great rest of your afternoon. Bye now.
Thank you.
Thanks, everyone. Thanks, Roberto.